This lesson is about measuring segments and angles. And what we got to focus on being able to do is we got to be able to communicate or talk precisely about angles, segments, undefined terms, and congruence. Secondly, we've got to be able to use what's called the segment addition postulate and the angle addition postulate. Now, the first slide, if you will, right here is a summary of everything that we need to know from this. We've got this ruler postulate that very simply says each number on a number line can correspond to one specific coordinate or point. We have a protractor postulate, which I'm assuming you have all used a protractor before, and you know how to measure an angle on that protractor. We have some things that are known as undefined terms in geometry. These undefined terms are the beginnings, or the things that we're going to accept to be true right off of the bat so that we can define this thing that's called geometry. So a point is simply a place in space or a location that has no size. All right? Notice how they are naming these also. A line is an infinite collection of points that are on a straight path that goes in opposite directions. A plane is an infinite number of points that lie on a flat surface. So think about like a wall or the floor or the ceiling. It extends, though, forever. So even though the ceiling eventually hits the wall, it's not going to stop there. The plane continues forever. Okay? Then we have some defined terms. These are now based off of things we've previously defined. We have these things. First one is called a segment. Sometimes you'll hear this referred to as a line segment. A line segment or a segment has two distinct endpoints, and it collects all the points in between. It is a part of a line. Okay, notice again how they name it. Naming it, guys, is that notation part right there. A ray is part of a line, but it's from one particular endpoint, or I like to think of it as a starting point, continuing through another point forever. We name it by always saying the starting point first. Okay? This is a unique term, but it's something that's come up over the last 20 years or so as a way to describe another way to describe a line. And these are opposite rays. So ray TU and ray TS would be considered opposite rays because they share a common endpoint and they're on the same line. Now, an angle is created by taking two rays. So let's look at ray QR and ray QP. If those two rays connect at a single endpoint, Q in this case, but they're not on a straight path, we create something called an angle. This is known as angle Q. If there's a number written inside of it, we can call it by that number. So we call this angle 2. Or we could call this angle PQR. And conversely, we could call this angle RQP. But notice this Q, that common endpoint, also known as a vertex, has to be in the middle. Okay, so example 1 here, it says, can you find some segment lengths? If I look at this picture, they want me to find the length of AC. I know that AC can be found by doing a multitude of things. I'm going to go ahead and count. How far is it from A to C? Now remember, when you're measuring, you're always going to have a positive measurement. So I'm going to go from left to right here. A is at -3. I'm going to count 1, 2, 3, 4 units to get to C, so I know the measurement of AC is 4. Now there's other ways that you can find that measurement. We're going to talk about them in just a minute. This ruler postulate I described before simply says every point on a line can be paired with exactly one point. All right, each coordinate and each point correspond to each other. Now the distance on a line is the absolute value between the two coordinates that we are asked to find. So if they want me to find the length of x, y, notice how I've got x is at 3, y is at 7. I can either go absolute value of 3 minus 7, which would give me absolute value of -4 or +4. Or I could go absolute value of 7 minus 3, which is 4. Absolute value of 4 is still 4. All right? So using this absolute value can sometimes make things a little bit easier. In this problem, they want me to find JK. Well, I know that JK is the absolute value of 5 minus 12. J matched with 5, K matched with 12. This is the absolute value of -7 or 7. How about Km? Well, I know that Km is the absolute value of, I still like to go left to right. You can go right to left, but I'm going to say absolute value of 12 minus 27. That's the absolute value of -15, which would be +15. Notice if I had found Km, but I did it kind of using M first, I would have absolute value of 27 minus 12, which is the absolute value of 15, which is still 15. Doesn't matter which way we do it. All right? Now we have a postulate. A postulate, by definition, very simply, is a statement in geometry that is automatically accepted to be true. That's what a postulate is. Now, the one that we're going to look at first is what's known as the segment addition postulate. And the way that I always like to think about segment addition is this. We're talking about the measurement from A to C. So how is AC made up? It's made up of AB and BC. So the segment addition postulate will tell me AB plus BC, AB plus BC gives me the whole big piece AC. All right, so we're going to bring a little basic algebra into the mix now too. All right, here's what I know. I know that GH is equal to 16. So this measurement right here is 16 from G to H. Now, they want me to find FH. FH goes this whole length right here. All right, in order to find FH, I have to know how big FG is. So in order to find this, I have to first find FG. FG is represented by this expression, 3x minus 1. In other words, I got to know x. So I come back over to what I was given. I know that 2x plus 2 has to equal 16. Why? That's what they told me. So then I have subtract 2 from both sides. 2x is equal to 14. Divide by 2, I get x is equal to 7. I'm now able to calculate the length of FG. FG is going to be 3 times 7, I substituted, minus 1. I substituted into that FG expression. This tells me that FG is equal to 20. So now I know this piece up here is 20. All right? And notice how it doesn't look like that on the picture, does it? All right? We have to rely on the algebra. Okay? But FG is 20, and they want me to find FH. So I know that FH here is made up of FG plus GH according to the segment addition postulate. All right, so according to the segment addition postulate then, I know that FH is equal to FG, which we just found to be 20, plus GH, which we just found to be 16, or FH is equal to 36. One key thing to point out here. Notice how in the picture, FG definitely looks smaller than GH. If you do the arithmetic correctly, we got the different measurements. Here's the deal, though. You cannot always rely on what a picture looks like. You have to use things like the segment addition, the postulate, all right, the properties that we're going to learn. So how about this one now? It says, use the segment addition postulate to find this. It says that J, K, and L are collinear. That means very simply, collinear means on the same line. They tell me that JL is 25. So they're telling me this whole big piece here is 25. All right? According to the segment addition postulate, I know that 3n plus 5n minus 7 has to equal 25. Little piece plus little piece has to equal big piece. I now use some algebra to solve. I've got 8n minus 7 is equal to 25. Add 7, 8n is equal to 32. Divide by 8, n is equal to 4. All right? The next postulate that we're going to deal with is called the protractor postulate. Similar to the segment addition postulate, the protractor postulate, I got ahead of myself, sorry guys, says that anything that you draw on here will have a measure between 0 and 180 degrees. Okay? In this first example, they want me to measure angle AEC. So remember, AEC says start at A, E is your vertex, end at C. So this on the outside starts at 0, and I notice C is up here, right here. That's about 105 degrees. So I can say that that's 105 degrees. I'm using, in this case, the outer numbers because that's where 0 was for A. Now, how about angle BED? Well, B starts here, E's in the middle, D starts there. All right, now I got to think a little bit. Where would you say that B is located? I'm thinking that B is at about 47 degrees. I think that D is at 130 degrees. So how am I going to find the measurement from BED, of BED, angle BED? Well, I could go back and use that idea that we had before of absolute value, all right? Or I could take the absolute value of always go the bigger number minus the smaller number. So if I do this, either way I do it, I end up with 83 degrees. 83 degrees. All right. Here's what I was saying before, guys. I apologize. The angle addition postulate is very similar to the segment addition postulate. And what this says is little angle plus little angle equals big angle. Angle ABD is this angle down here. From A to B through D. Angle DBC is this angle right here. From D to B through C. All right? If I add them up, I get this big angle, angle ABC. So little angle plus little angle equals big angle. All right? Let's take a look at this now. All right? I want you guys to try to figure this one out on your own or use your online book to try to help you to figure this out. All right? So again, that was this example. You're going to see one like it on some of your online homeworks, but I'm kind of leaving it open-ended to let you guys figure out how to do it. I'm going to do one down here very simply. Okay? Here's what this says. Angle SPR, that's this angle right in here, is 59 degrees. Angle SPQ, now that's the big angle. I always like to write this out here and put a circle around it, just reminding me that's the big angle. They want me to figure out what this angle is there. Now, I'm going to go ahead and call this X so that I can do it algebraically. I know that angle addition says this. If I take the little angles, X plus 59, add them together, all right, that has to equal the big angle. So then if I subtract here, subtract 59, let's see, that would be 61 degrees. All right, how we doing, fellas? We're almost done. So we have this other concept that we need to make sure that we understand, and that's how we determine when things are congruent. I like to refer to these things, that they do too, as tick marks or arc marks. If I have two single tick marks, that's telling me that these segments are congruent to each other. That means they're of equal measure. If segment AB was 10, then I automatically know segment CD is 10. For angles, we do the similar kind of tick marks, but they call them arc marks, and they're interior or inside the angle. Okay? Right here we have some properties of equality that you should familiarize yourself with. Reflexive, symmetric, and transitive. Hopefully you have seen these before in school. If not, let me know. We'll go over them a little bit more precisely with each other. But these are reflexive, symmetric, and transitive properties. We have to know their names because we're going to be using those names down the road. All right, let's take a look. This is almost the last example. All right, here we go. Thanks for bearing with me today, guys. They say the measure of angle XWZ is 127. XWZ, that's the big angle here, is 127. They say, what is the measure of angle YWV? YWV is this angle in here. I'm going to call that X. Now, I notice here that I have an arc mark here and an arc mark here. That's telling me because this angle is 32, then this angle has to be 32. I see angle addition. We just, instead of having two little angles, we have three. So here we go. I'm going to say 32 plus X plus 32 has to equal 127. And when I find X here, that's going to be the missing angle. So this will be X plus 64 is equal to 127. Subtract 64, I get X is equal to 63, which is the measure of angle YWV. How about this one? They want me to find the measurement of HF. Now, first thing we got to do is find HF. HF is this big piece out here. That's what we got to find. Now, the first thing is I need to figure out what is either HG, because I see segment addition. Figure out what HG is or figure out what GF is. Now, I see one tick mark on GF. I see one tick mark up here on BC. Therefore, I know that this is 8. I see two tick marks here. I see two tick marks at 11 centimeters, so I know this is 11. Look how easy this problem just became. I'm going to call this X, just so I have a variable, and I know that X is equal to 11 plus 8. That's segment addition. So I would say X is equal to 19, because they gave me a label, I'm going to label it centimeters, and that's the measurement, that's the measurement of HF. All right, let's take a look here now. These are just two more problems just like the one before. I think we're good. Okay, I think you guys can figure it out from here. Let me know if you guys have any other questions. I apologize for the length of the video, but you'll understand why when I explain it at some point. Good luck on doing the assignment that I have for you on Moodle.